Hi everyone, my name is Juan Pablo. Welcome back to a new YouTube video. And in this time, we will continue showing basically different variations of a feature that we have previously seen in the last 3-4 YouTube video that we have uploaded into the channel. That feature particularly is called perform measurements. So I will just draw the line over here. This feature basically that we have seen across the last 2-3 videos in the YouTube channel is called perform measurements. Okay, and we have been seeing in the last videos that we can use this feature to basically calculate the low latency path between PE devices for a specific customer. Okay, so for example, if I have here in the diagram SR9K1 and we continue still using our very common topology that we have been using in the last videos. So if here we have SR9K1 a BRF for serving R4, we have XR9K3 as well a BRF for serving R5. So basically R5 and R4 are customers of ASR9K1 and ASR9K3. And if we want to calculate the low latency path for that particular traffic between R4 and R5 across the core to follow the low latency path, we need to enable perform measurements across every single link. Okay, we need to enable perform measurements to be able to calculate that path and basically that SRT policy that will be low latency. Okay, that's one variation of perform measurements, using the delay across the infrastructure to calculate a traffic engineering policy with the low latency path. Okay, that was basically the first use case that we have seen in perform measurements. And the second use case that we will see now and today is basically how we can calculate the latency inside of already created SRT policy. Okay, so we don't want to, in the traffic engineering policy, we don't want to calculate the low latency. We just want to know what is the latency of the SRT policy already existing in the network. Okay, so we want to calculate that, and that's another variation that we can use this feature performance measurement. Okay, if you have seen also the last videos, if not, I would recommend you to look at. When we configure perform measurements, we actually start with perform measurements, right? And there is a delay profile, right? And in that delay profile, we'll put interface in the last video. And if you put question marks, there are many options that you can configure that delay profile. We will take a look in the CLI as well, but there are many options. And one of these options for those delay profile in that configuration is called SR policy. Okay, SR policy. And again, what it does, simply send proof packets across the current already instantiated SRT policy. So basically, if I configure the perform measurements for the SRT policy, what it does is that if XR9K1 have already a policy to XR9K3, so this between the P devices, and let's say that the policy that he has to XR9K3 is manual policy. Okay, so policy between R1 to R3 is a manual policy, and let's say that the path is defined by the low IGP metric. That policy was created by that purpose. Let's imagine, and we will actually do this in the lab. So the policy is created by the IGP metric. Then we can insert under this policy our profile of segment routing policy for perform measurements. And what actually it will do, it will basically go hop by hop for all the paths that this policy goes between ASR9K1 and ASR9K3. So basically this policy, again, we configure in ASR9K1. It goes hop by hop and it capture the delay end to end. Okay, it captured the delay end to end for that particular policy. Okay, so of course, this is more between PE devices, right? It's the delay between PE devices. It's not the delay between the links. Again, if you see the previous videos, when we enable perform measurements at the interface level, we try to calculate the delay in the link between two devices. This feature, if it's enabled under an SRT policy, it doesn't calculate in the link, but instead it calculates end to end. between both PE devices. Okay, so this feature is again for configuring for the SRT policies and calculate the latency for that particular policy. Okay, now what is the difference if we deep dive a little bit more into this feature against to the feature that the same feature but configured under the interface, is that perform measurements under the interface only cares about the important delay. Remember that in the previous formulas as well, we will ignore in the time that every router process the packet and send it back, right? So if we had, for example, 2 routers and we enable perform measurements in this interface with the delay profile interface, this router was sending traffic and then he was sending the traffic, and within perform measurements, of course, there were 2 ways to configure, right? But in both ways, they were ignoring the processing delay of the router. So we just care that when we send until the router in the other side receive the packet, we just care about this delay. We don't care about that this router process the packet internally and send us back the packet. We don't care about this processing delay. We don't care about this sending packet. We just care about the traffic or the times between that the packet leave and arrive to the other router and hop, right? In this case, for SRTE, perform measurements in SRTE, we consider as well this time that every router process the packet, because in this case, ASR9K1 will send the packet to ASR9K2 with destination of ASR9K3. ASR9K2 will process the packet and will send to ASR9K3. ASR9K3 receive the packet and put it back to the network, so send it back to this router to process this router and then send it back to ASR9K1. So in this case, ASR9K1 is basically caring about the timing that, for example, ASR9K2 process that packet for sending to ASR9K3. So we consider that delay into the equation, okay? Because there is no way to avoid that delay. And of course, we want to consider because it is within our time frame or range of measuring that we want to achieve. Okay, so saying that about that feature, I want you to take with this concept. Perform measurements has many delay profiles. You can enable at the interface level, you can enable under the segment routing policy level, you can enable under RSVP. There are many profiles. Now we will go over the SR policy profile. Okay, so what we need to do actually in the network, we first need to make sure that ASR9K1 has the policy, manual policy to ASR9K3. So if we have, let's take a look quickly, if we have that policy, we have that policy already enabled. So ASR9K1, so P1 in this case, have the policy towards P3, okay? We have the policy and the metric type is the IGP. So that policy should be already created. So if I put color policy, the policy is already instantiated in there. But we cannot see any delay information over here, okay? We have the policy, but we don't know how much or how is the latency to reach that particular PE device. In this case, router 3, okay? So let's proceed to enable this feature. Basically, we need to do perform measurements, delay profile, and here is the profiles that I told you that there are many of them. We'll just choose SR policy, okay? Default. Then here we need to basically enable the proof packets that we'll be sending. Within proof packets or within the proof options, we have many ways or many things that we can configure. Computation delays, for example, we can configure boost interval, how often we want to send the proof packets. We can even configure the type of encapsulation with protocol, for example, as well. There are many options that we can apply here. We will just leave to the simple way that is needed, just proof, and that's it. So I just commit. So if I check again the configuration that I did here, show runs the perform measurements, I just configure the SR policy, and actually here I will just put proof, and I think it got configured. Let me just take a look. I just want to make sure that this actually sending the proof packets. I think it's by default already settled, but I will just put here proof measurement mode 2 ways. This also you can do as well under this perform measurements configuration. You can configure as well what measurement mode you want, which is in this case 2-way. Okay, so I just configure 2-way, and I can add more details, but I will not do it. Okay, so now once we have the SR policy for the perform measurements configured, we need to add this perform measurements delay profile under our segment routing traffic engineering policy. So we need to go under segment routing traffic engineering in the policy, and here perform measurements delay measurements, and this here delay profile name. This is in case we have a name really already explicit configured. If we just leave it as default, as we did here with the SR policy default, we don't need to configure anything, just delay profile, even delay measurements only. Delay measurements. Let me just take a look. Yeah, perform measurements, delay measurement only, and that's more than enough. So we actually commit, and basically that's it. What we can or we have to do, basically configure the SR policy with the default profile. We can configure some proof options if we wanna tune the timers, for example, of the proof packets or the computation of that delay, how often we want to compute with the computation interval. We can configure many options over there. We can configure the measurement mode as well, but essentially you just need to configure the SR policy profile default, and that's it. And attach, of course, under the traffic engineering policy. How we can verify? Well, we can verify with a simple command show perform measurements SR policy. If we check the information under the SR policy, we can see that there are many values already in place. Like for example, the next advertisement, and here actually we see the delay packets for this path. But before going that, of course, we see the SRT policy that goes towards the router tree. The color of the prefix of that policy is 100, which was already instantiated. The endpoint is 3333. Here we see that the profile type is segment routing policy delay measurement. So this is the SR policy profile. The source address is the 1111, which is the loopback 0 of router 1. And again, we see more information on the delays calculated on this profile specifically. Okay. Here I think we can also check more information with show perform measurements, SR profile, detail, if I'm not mistaken. Well, detail, here we can see, I think not much more options. There is another command that is very, very interesting, is counters, SR policy. In this show command, we can see actually how many packets has been sent, how many packets has been received. This is very important because we want to make sure that actually the packet is going and is back. Because when it's back is when we can basically calculate the latency towards P3. We send to P3 and we wait till the packet is back so we can calculate the latency. Of course, if we don't see total received packets, then it means that the packet is being dropped somewhere in the middle. So router 3 might be sending the packet, but it's being dropped somewhere in the network. So we always want to make sure that these two fields are filled out. Okay. It's very important, again, that all these show commands are available in telemetry. There are already young models available for these commands, so you can export into your telemetry server. I think SNP is very limited with perform measurements, but you can export it for sure into telemetry server, and it's already available for some time already. Okay. There is another command, I think, show perform measurements story advertisement, if I'm not mistaken, SR policy. Here you can see a bit of more of basically a bit more detailed information as well for the story of the delay measurements. So here we see one, but of course, as far as we have more packets being sent and more time, there will be a more entries into this story show command. Okay, so here you can monitor if actually in that particular time the packets has been sent or received, what was the average delays in that particular moment, All of this information is very useful for operations, and of course, everything of this is exportable to telemetry as well. Okay? So that was the video for today. I hope it was not that long and you have learned something. This feature again is very useful for manual policies that are already pre-created and you want to know specifically what is the latency for those policies. It's not the same to enable SLA globally in the device and put to the other PE between PEs to put SLA, because this policy goes specifically for this customer. Okay, if you put SLAs, it will be globally in the device. So under the policy is always much better, because the policy might or might not have, actually most likely might have different path than the normal routing between the PE device. So it's very, very interesting feature to enable. Okay, thank you very much for watching the video. Last announcement I want to do is that I will run a bootcamp for segment routing and SRv6 in the next month, June 13. So if you're interested into learning more about segment routing technologies and SP technologies overall, feel free to send an email and to ask for more information or join the bootcamp. We will talk and deep dive into segment routing, into SRv6, and all of these functionalities that can really solve real use cases. So I invite you to join the bootcamp and to learn together. Thank you very much again for watching, and see you in the next video. Bye bye.